In this video, we are going to go over how to use these three properties of logs to expand single logs into multiple logs. Let's look at our first example. Here we have the log base 7 of an 11 raised to the 20th over a 6 raised to the 4th. So first thing that should be standing out to us is we have this fraction right here. That is a quotient property, so we can automatically expand this single log into the difference of two logs. So we would start by taking the log of the numerator, and then we would subtract the log of the denominator. So we have a log base 7 of our numerator, and 11 raised to the 20th, and then we're going to subtract a log base 7 of our denominator. That's 6 raised to the 4th. Now, what should be standing out to us is those exponents. We can use the the power property to move those out in front of the log. So that raised to the 20 here can be moved out front based on the power property. So we can make this a 20 times the log base 7 of the 11 minus, and that 4 we can move out front based again on the power property. So we'd have minus the 4 log base 7 of the 6, and this would be our expanded answer. Let's look at a second example. Here we have the log base 4 of a 5 times a 3 times an 8 to the 5th. So all three of those numbers there are being multiplied, so that is our product property. We can combine this into expand this into 3 logs, one of each of those numbers. So this would become the log base 4 of 5 plus the log base 4 of 3 and plus the log base 4 of an 8 to the 5th. So we have expanded that single log into these 3 logs, and what should be standing out to us is that 5 right there. We can use the power property to move him out front. So we still have our log base 4 of 5 plus our log base 4 of 3 plus move that 5 out front, so 5 times the log base 4 of 8. And that would be our final answer. Let's look at a third example. Again, this looks very similar to our previous example. This is the product property because of the multiplication, and that last number there, that 5 to the 4th, is going to be a power property. So we can go ahead and start expanding. This would be a log base 7 of the 11 plus the log base 7 of the 6 plus a log base 7 of the 5 to the 4th. Now that we dealt with the product property and expanded it to the 3 logs, we can now move this 4 out front using the power property. So we have a log base 7 of 11 plus a log base 7 of 6, and finally plus the 4 times the log base 7 of 5. And this would be our final answer. Let's look at a fourth example. Here we have a log base 9 of an 11 times a square root of 12 times a square root of 5. Those 3 numbers there are multiplied, so we can use our product property to expand this to 3 separate logs. So we have a log base 9 of 11 plus a log base 9 of the square root of 12 plus a log base 9 of the square root of 5. And now, this looks like we could be done, but if you look at this right here and this right here, they're both square roots, Right now there's no exponent, but you can rewrite a square root as an exponent. So those are actually a 12 raised to the 1/2 and a 5 raised to the 1/2. So let's write that down just so we can visualize and see what we're doing. So that is a log base 9 of a 12 raised to the 1/2 plus a log base 9 of a 5 raised to the 1/2. Now it matches our power property. So we can take that 1/2 and move it out front of the log, and take that 1/2 and move him out front as well, based off of the power property. So we have a log base 9 of 11 plus move that 1/2 out front, log base 9 of 12, and plus move that 1/2 out front, log base 9 of 5. And this would be your final answer. In this next example here we have a log base 8 of 2 to the 4th over 5 to the 12th. That fraction bar there tells us this is a quotient property, so we can automatically expand this into two logs. The log base 8 of the numerator, that 2 to the 4th, minus the log base 8 of the denominator, that 5 raised to the 12th. Those exponents we can work with using the power property, and they get moved out in front. So we have a 4 times the log base 8 of 2 minus a 12 times the log base 8 of the 5. And we look at this, there's nothing else that we can do to expand this. This would be our final answer. Let's look at another example. Here we have a log base 5 of w squared times the square root of u. So it's not wrote there, but there's actually a multiplication in between here. So let's go ahead and put that in. So that multiplication in between tells me I can use the product property. So I can expand this into two logs. The log base 5 of the w squared plus the log base 5 of that square root of u. We have an exponent here we can deal with. He gets moved out front based off the power property. So we have a 2 times the log base 5 of w plus, and we can rewrite that square root, can cancel him out and write him as a 1/2. That is the same thing as a square root. So now I can take that 1/2 and move him out front. So we have a 1/2 and a log base 5 of u. And there's nothing else we can do to expand, so this would be our final answer. Let's look at one more example. Here we have a log base 4 of x raised to the 10th over y raised to the 5th. Again, that fraction there tells us this is a quotient property, so we can expand that into two different logs. We have the log base 4 of the numerator, x to the 10th, minus the log base 4 of the denominator, that y raised to the 5th. Now we look at this and should notice that these exponents represent the power property, so we can go ahead and move them out in front of the log based off of the power property. So we have a 10 times the log base 4 of x, and then minus the 5 times the log base 4 of y. And there's nothing else we can do based off our properties, so we can go ahead and circle that as our final answer. One last example here. Looking at this guy, looks a little complicated, but it's really not that different from what we've been doing. The first thing we notice, we have two things multiplied together, so we can use our product property to write that as two separate logs. So we have the log base 2 of z plus the log base 2 of a cube root of x, y. Now we look at this, and that cube root we can rewrite as an exponent. So if we rewrote a cube root of x to the y, we could rewrite that as an xy all being raised to the 1/3. So we can replace a cube root of xy with the xy raised to the 1/3. So let's go ahead and erase this guy and replace him with the other way of writing it. So this would be an xy all raised to the 1/3. So if you have two things all being raised to a 1/3, that would be the same thing as both of them being raised. So we would take that 1/3 and place him into both the x and the y. So we'd have a log base 2 of z plus a log base 2 of an x to the 1/3 times a y to the 1/3. Again, we have multiplication in here, so we can expand into another log. So we have a log base 2 of z plus a log base 2 of the x to the 1/3 plus a log base 2 of the y to the 1/3. Now we can deal with our exponents based off the power property and move them out in front. So we have a log base 2 of z plus a 1/3, moving that 1/3 out front, log base 2 of x, plus move that 1/3 out front, times the log base 2 of y. And there's nothing else we can do to expand this problem. So this would be our final answer.